Okay, now we're going to link what we learned to the whole hydrologic cycle. So where's the water on the planet? What can be found as liquid water, solid, ice, or vapor? Water molecules are also found within cells and tissues of the body, and it's constantly moving, right? The water cycle. So here we go. So imagine the heat, energy now required to get a phase change from a liquid to a gas. How much energy would be required to convert it? How about how much energy is going to be given when we get the temperature change and the condensation forms goes back to a liquid? Or how about when it turns into a solid? So we want to now look at this in terms of energy. So yeah, just some basic things here. Plants, we know, use a lot of water. Any unused is returned via transpiration by plants. Most of the water, 90% returns to the atmosphere through evaporation from large bodies of water. Okay, so phase changes. Water undergoes many phases. Ice, water, and water vapor, right? Whenever water changes phases, thermal energy is released. Now, this is where it gets a little bit confusing. When ice goes to water, is energy release or absorbed? We would actually absorb energy. But when water goes from water to a gas, it releases energy. So that's going to be negative, and this is going to be positive. Absorbed, energy released. So why is energy absorbed or released? When a substance goes from one of those, the bonds between the particles become weaker and break. This process requires energy to break those bonds. Therefore, breaking bonds always results in the absorption of energy, breaking the bonds. Okay, that's why going this way requires absorption of energy. Remember what these bonds are. These are H2Os, and there's my hydrogen bond between two water molecules. They have to be broken. In contrast, when substance goes from gas, liquid, solid, new bonds are formed. This process releases energy. Things warm up just a little bit before it starts to snow because things are going to go from a liquid to a solid snow. Now we get this graph here. When bonds break or form during a phase change, the temperature of the substance does not change. So notice here on this graph, no temperature changes are occurring here. These are phase changes. Here's my first phase change, melting or freezing. Boiling, and the opposite is condensing, is the second phase change, but the temperature stays at 100. Temperature stays at 0. So melting and freezing occur at 0 degrees Celsius. Boiling or condensation occurs at 100 degrees Celsius. This occurs because the energy is used to break or create bonds between the particles. So when energy is breaking or creating bonds, there is no temperature change. So the energy is not available to change the temperature. Water molecules undergo many phase changes. This means a lot of energy is transferred in the biosphere without any change in the temperature of the water. This helps keep the average temperature of the Earth relatively constant. So we now have another term here, fusion, bringing things together, the heat of bringing things together. It takes energy to weaken or break the bonds of a solid. So, yeah, okay, in order to change it to a liquid. The amount of energy to melt 1 mole of a substance is called the heat of fusion. And moles, you might remember in chemistry, is the amount of a substance in chemistry. Different substances have different heats of fusion. So when the substance changes from a liquid to a solid, it releases the same amount of energy it absorbed to become a liquid. Heat absorbed equals heat released. Heat of vaporization, it takes lots of energy to evaporate a certain amount of a liquid. That is called heat of vaporization. Again, as a gas turning into liquid will release the same amount of energy it absorbed to become a gas. Heat absorbed equals heat released. Okay, so let's try some calculations. Once you know the heat of evaporation or fusion of a substance, you can calculate how much energy it takes to melt or vaporize a sample. And here is the formula. Heat of fusion is the amount of energy over the number of moles, right? This is my energy. So joules per mole. Q is in kilojoules. N is the number of moles. And you rearrange this, we can get the amount of energy is the number of moles times the heat of fusion. Okay, so the heat of fusion of water is 6.01 kilojoules per mole. Determine how much energy it will take to melt a mass of 250 grams of ice. Well, ice is H2O, and the molecular weight of water is 2 hydrogens and 1 oxygen. 2 times the molar mass of hydrogen and 1 times the molar mass of oxygen. Now remember, these are grams per mole for both of them. So we're going to get 2.01 and 16.00. That works out to 18.02 grams per mole. Okay, so Q is equal to 6.01 kilojoules per mole. Okay, and now we've got to calculate the number of moles. Well, if we go back to our calculations, I've got M and molar mass. So using these two, I can calculate the number of moles is mass over molar mass is 250 grams divided by 18.02 grams per mole. And this is going to give me 13.8 moles. So now I substitute 13.8 here. My moles cancel out. I'm left with kilojoules. I'm going to multiply that by 6.01 and I get 83.4 kilojoules. 3 significant digits. So these are two-part problems. I had to calculate the number of moles first, and that required for me to calculate the molar mass of water, of ice, H2O. Okay, this second sample question I am going to let you try. The heat of evaporation of water is 40.65 kilojoules per mole. Determine how many grams of water at 10 degrees, 100 degrees Celsius you could evaporate with 100 kilojoules of energy. Okay, so go ahead and do that now. The answer is 44.3 grams. So see if you can arrive at that answer.